Hey everyone, in this video you're going to learn exactly what a DevOps engineer and site reliability engineer does at large software companies. So in this video we're going to go over some large software systems, how those software systems work, and the type of problems that DevOps and SRE are trying to solve. And I'm going to go over the tools that they use to solve these problems and the automations and observability tools that they build to achieve those tasks. So this is going to be a really good video for people looking to get in the industry and just have an understanding of the big picture. I recommend this video more than just looking at one of those DevOps roadmaps. This is going to be a more practical guide to what you actually need to know and understand and learn, and why we're learning it. And towards the end of the video, I'm going to get a little bit into career progression in the industry. So the first thing that we want to talk about is the three different roles: developer, DevOps, and SRE, Site Reliability Engineer. These are job titles that you're going to see in the industry quite frequently. Now, what these actual roles entail is really going to be dependent on the company you work for. Some companies like to pretend they're software companies and they just name their engineers DevOps engineers. These are just titles that we sort of throw around, but I've tried to quantify these roles into what I would expect these people to do. So a developer is all about designing and creating software. A DevOps engineer is all about reducing friction in the delivery of software. And a SRE to me means a site reliability engineer. They're making sure that there's stability in the system. So I think the best way to actually understand this is to have a look at a large software system and just have a look at how these different roles are involved in creating that ecosystem. So let's go ahead and create our first diagram here. All right, so we're going to keep our first diagram really simple here. And let's just add a server here. So we have a server, and basically we want to get our application to the server. So we have a developer that writes our code. That code gets stored on a code repository, and then it gets delivered to the server. But before it can actually get delivered to the server, we have to do a few things. We have to compile the code and build it in a way that the server can run it. Now, this is usually done through what's known as a CI/CD pipeline, and this is something that the DevOps engineer helps with. So the DevOps engineer builds what's known as a pipeline, and then the pipeline does the code building, and then it actually can deploy the code. So there's usually more than one pipeline. We have pipelines for building the code as well as deploying the code to the servers. Now, how do those servers actually get put in place? Well, usually we have infrastructure as code. Since these are cloud-based systems, we can use tools like Terraform to build our infrastructure. So we usually have something like an infrastructure repo. And this is the repo that the DevOps engineer works on. So now that we have our system, we have our different repositories and our pipeline delivering our code to that system, we need to monitor that system and make sure it remains healthy. So we have monitoring tools and observability platforms plugged into our different systems. And this is sort of where the responsibility of the site reliability engineer comes in. So the site reliability engineer is somewhat responsible for the servers and the cloud infrastructure and monitoring those servers. And the DevOps engineer is sort of about building the pipelines, building the automations that creates the infrastructure. And the developer here is responsible for actually designing the application. There's actually quite a bit to that. I don't want to undersell that, but mostly what we're going to go over for the rest of the video is what the DevOps engineer does and what a site reliability engineer does, because that's what this channel is all about. So let's go ahead and look at a more real-world diagram here. So most of the infrastructure you're going to run into looks pretty much like this. This is basically what you're going to see most application and infrastructure is designed like. You may see more complicated diagrams, but they can sort of be simplified to this. let's add in some end user devices. So this would be your customer coming in to your application. So the customer's coming in from the internet, and let's just pretend they're using something like Netflix, Uber, or an application like that. So the end user is going to come in and they're going to talk to the application through DNS. And DNS will then route the traffic to a data center. So you may have one data center, but most large enterprise companies are going to have multiple data centers, and they could route the DNS queries based on geolocation, right? That's how most large applications work. So DNS is going to route them to a specific data center, and they're going to hit a load balancer. So that load balancer is going to take their traffic and route it to whatever their compute platform is. So that could be something like a Kubernetes cluster, or it could be something simple like just a bunch of servers running in an autoscale group. Usually there's some sort of way of automatically scaling the amount of compute instances. So there's going to be some type of compute platform. There's also going to be other infrastructure resources, such as the persistence layer. We're going to have things like databases, S3 storage, as well as like the load balancer itself. There's tons of other infrastructure services that make this all work. So let's take one of these data centers and break down some of the responsibilities that we have as DevOps engineers to actually create this and make it happen. All right, so we have our data center here, but how do we get to this point? Well, usually we have what's known as infrastructure as code. So let's put our infrastructure as code right here. And basically what this is going to be something like Terraform. We're going to use tools like Terraform to build all these infrastructure resources. So we're going to build things like load balancers, servers, databases. We'll even create our DNS zones, our DNS records. We can all manage this through tools like Terraform. Now, Terraform isn't the only infrastructure as code tool that you're going to see out there. There's a few more, but Terraform is by far the most popular one. So if you're looking to get into this side of DevOps and SRE, make sure you pick up Terraform. Now, the other thing I like to mention about infrastructure as code is we have to think about how we're actually applying this infrastructure as code. So actually building the configurations in Terraform is just the first step. We have to think about how do we actually apply this to our infrastructure and make sure that the state doesn't drift. So there's tons of tools and automations that we can use and build that applies our Terraform for us. So usually I don't like it when people manually apply Terraform, but usually I like to build this into some sort of infrastructure management pipeline. So I'm just going to put automation here, and let's draw an arrow. And if you have any questions about this automation step or what tools you can use to automatically apply your Terraform, let me know in the comments and I'll give some recommendations. Now, creating your infrastructure is good, but our infrastructure actually needs to be configured. So things like servers need patching, they need software installed on it. This is what's known as configuration management. So I'm going to put configuration management here, as this is a big responsibility for our DevOps engineers as well as our SREs. And I have Ansible in my config management of choice, but there's tons of different config management tools. The four most popular ones are, of course, Ansible, Chef, Puppet, and Salt. Those are the four that I hear the most about. I would say Ansible is the most popular one right now. If you're going to learn one right now, make it Ansible. Chef and Puppet are sort of old school ones. They're good to know because you're probably going to end up working for a company that uses these tools, so it's good to know them. But from my understanding, these tools are being phased out. So creating your configuration management playbooks and recipes is going to be a responsibility for that DevOps engineer as well as the SRE. And one of the things that you'll be doing is also thinking of ways that you can automatically apply your config management to your systems. So what happens to your systems is over time they drift from the configuration. People can go into the systems and manually make changes, install software, uninstall software. things change in computer systems, so we need our config management playbooks to be constantly running against our system to bring it up to the state that we have defined in our config management templates. So that's going to be one thing that you have to design as an engineer, is how do we design a system to be running these playbooks against our systems. Another thing that you might do for config management is create what's known as an image pipeline. So our servers are created with machine images. So you can think of this like a virtual machine image, or if you use Amazon, this is what's known as an AMI. This is what you start your servers with. And basically what you can do with config management is you can combine it with other tools to make a pipeline to create these machine images. So you can have an up-to-date machine image that has the latest patches, the latest versions of all the software you use, and you can use that to provision your servers. Most of the time, your servers are going to be controlled through an autoscale group that you created with your infrastructure management tools, and then that autoscale group can use your machine image that you created with your config management pipeline. So a big role of an engineer, DevOps and SRE, is understanding the infrastructure as code tools as well as the config management tools and how we can combine them to efficiently make our systems and make sure those systems are always up to date and they don't drift from our configurations. Now, this is just the infrastructure side of getting your application up and running. The other side is actually building that application and getting it deployed to this infrastructure. So there's two more pipelines I want to talk about. The first one is, of course, the code pipeline. So this is your traditional CI/CD pipeline, and I have a whole video dedicated to it. If you want to check that out, I'll go ahead and link it in the description as well as post a link here. But basically, to summarize, it checks out your code from GitHub, it automatically creates what's known as an artifact, and then it deploys a container image to an image registry. Our servers can then pull that image down from the registry and run our code. Now, the second part that comes with your continuous integration and continuous delivery pipeline is the continuous deployment pipeline. So the continuous deployment pipeline is basically your automated strategy of how to get the code from your image registry onto your servers. And this is another big responsibility for the DevOps engineer, creating and maintaining these pipelines, as well as being involved in the design process of these pipelines, is something we do day to day. All right, so we have one final diagram to go over here. And this is all about observability. So basically, we have these systems that we built with our infrastructure as code. We configured it with our configuration management pipelines, and then we built our application and deployed our application with our other application pipelines. But once the code is deployed there, we need to actually monitor the system to see how it's performing. So one thing that's really different in cloud computing and these large applications is the way that we troubleshoot them. Back 5-10 years ago, the way we would troubleshoot an application is you talk with the user, you figure out which server they're connecting to, then you log into the server and you look at the logs and figure out the problem there. That does not work in large computing systems. So what we have here is 3 different data centers, and they could be running hundreds or thousands or hundreds of thousands of servers. And if a user is having an issue, it's like finding a needle in a haystack. So what we need to do is plug in observability tools that help us understand exactly what's happening to our systems. And this is a big responsibility of the SRE, and the DevOps engineer is also very involved in this, right? But I would consider this more on the SRE side, but of course, everything is sort of shared in this world. Now, when it comes to observability, I would say these are the 5 key things that you need to understand and track in your systems. So we have metrics, APM, dashboards, log aggregation, and alerting. So these are all things that are extremely important on understanding our system. So the first one here is metrics, and these are basically health indicators for your system. So metrics can be anything from your CPU usage, your memory usage, how many servers are online, what the application response time is. There's literally hundreds of thousands of metrics on your systems that you can monitor. And as engineers, we're going to be designing how we actually collect these metrics from our systems. So a common tool we use for tracking metrics is Prometheus. So basically what Prometheus can do is it can go to your different servers, your different containers, and scrape them for all the metrics. So Prometheus is a big tool for that. Now the next one I have on here is Application Performance Management. And this is basically the same thing as metrics, but these ones are more specific to the application. So usually for this one, what you have is some sort of instrumentation developed inside of your application. So what instrumentation is a way for the application to report certain metrics that it has. So one thing you may do if you had some sort of application is maybe you want to measure the amount of time it takes the user to log into your system, or the amount of time it takes the user to run a search. So these would all be APMs that you want to monitor. Now there's tons of tools out there for APM. I'm just going to put Datadog on here as an example. Now the third thing here is our dashboards. So one task that you're going to have is to actually create dashboards. We have all these tools like Prometheus and Datadog that help us collect metrics, but those metrics need to be visualized. They don't make a lot of sense if you're trying to read just the numbers. We need this visualized in bar graphs, line graphs, pie charts, and heat maps. There's tons of different dashboards you can create, and it really helps you understand and see how your application is performing, how your system is doing. So creating these dashboards is a huge task that we have as engineers. And my favorite one for creating dashboards is Grafana. So this is probably the most popular open source one out there right now. So if you haven't checked it out, I would recommend checking it out. Now the fourth one we have here is log aggregation. So this is a different way of troubleshooting your application. So the metrics in the APM are good for visualizing what's happening in your application, but sometimes we need application logs to understand what's actually happening when those errors happening. So we need to come up with a log aggregation strategy. So we have all these different servers, they're all generating tons of different logs. Basically, we need to ship those logs to a logging database, and then we need a way to observe those logs. There's tons of different log aggregation tools out there. I've used a bunch of them. I'm just going to put Splunk here, as I think this is going to be the one that most people recognize, but there's tons of them out there. Now the last one here is alerting. So alerting is a big task for the DevOps engineer and the SRE. Basically, we need to create alerts when any of our metrics are indicating that there's a problem with our system. So basically, the alerting is going to plug into all these other systems that we've created, and when there is a problem occurring, it's going to notify our team and let us know. So there's tons of different alerting platforms out there, but usually what these systems do is they notify users through PagerDuty, or they send a message on Slack, or send an email. So there's tons of different systems that we can integrate our alerting into. So building these alerting systems and plugging them into all our different systems is another task that our engineers are responsible for. So anyways, I hope this is starting to make sense and build a picture of what the day-to-day tasks an engineer will have. Basically, it's implementing all these systems. All right, so the final thing I want to go over here is a little bit about career progression. So we talked a lot about what these different roles do within the software industry, so we should have a good understanding about that. Let's now understand what a typical career ladder looks like. So on the left, I have a career ladder. It starts at a junior position, so it might be an intern. This could be a junior engineer. That would develop into an engineer. Then you have senior engineer, staff engineer, senior staff engineer, and principal engineer. Now, every company is going to be different with the job titles that they give out, but they usually follow a progression ladder like this. Now, where you end up in the career ladder depends on your experience level as well as how well you interview. All I really want to say here is there's tons of opportunity when you're getting started. Everything that I mentioned in this video might seem complicated, and you might feel like you don't know any of these tools and you don't know what infrastructure as code is. Maybe you don't understand configuration management or how you can get log aggregation to work. But a lot of that doesn't matter when you're first getting started out. So if you're getting hired as an intern or a junior engineer, you're probably going to be assigned tasks where another engineer ends up helping you. What really matters is you can sort of be self-sufficient and you're eager to learn, and you can pick up a topic, research it, and figure out how to solve the problem. As long as you can keep solving problems, you can move up this career ladder. It just takes time. Now, the further you move up this ladder, the more you're sort of expected to know and be responsible for in the different systems. So that's all I really wanted to discuss in this video. Please let me know if there's any questions about any topics that I went over in the comments below, and I'll get back to you. And if you disagree with anything I said in the video, please let me know as well. Anyways, thanks again for watching, and I'll see you in the next one.